Hello everyone, this is Balakrishnan, 20BZ1035, and I'm here to talk about Bitcoin. So, what it is all about, okay? So, Bitcoin is the first implemented cryptocurrency. Okay, now you may ask me, what is cryptocurrency? So, just imagine cryptocurrency as a normal currency. It's like how you have Indian rupees, US dollars, UK pounds. Similar way, cryptocurrency is something. It's also a currency which is used for payment purposes. Okay, at the end of the day, it's all about making transaction between people. Okay, so more technically, if I speak, what is cryptocurrency means? It is nothing but it's a big ledger. Okay, ledger notebook, account notebook, and if you subtract the complete trust factor from it, and if you bring security with some cryptographic techniques, right, then it is called as cryptocurrency. So, let me now tell some cool facts. Okay, like why did I choose Bitcoin, and why not some other coin, or why did I choose this, and then why are we going to study about this? Okay, like listening after this, you may feel like wow. Okay, so Bitcoin is the as I told you, it is the first implemented cryptocurrency, right? So it has a biggest market cap of 1.15 trillion US dollars, and then it's about 47% of market capitalization of cryptocurrencies, and then there are almost like 100k Bitcoin millionaires, okay, millionaires in Bitcoin, okay, and then India is the second largest country after US, okay, with 27 million users. So listening to all these things makes sense that to know about how Bitcoin is functioning, right? So now let me tell you. Okay, so now we have one doubt. Okay, see, before moving to everything, right? So we may have a doubt, right? Like, okay, physical cash is not there. So the same thing is done in the net banking also. Like in net banking also, we make transaction with people without physical cash, right? It's all about internet, and in internet we can make, right? Like, so what is the difference? Okay, if you see, that is the main difference is centralized and decentralized. Okay, let me put it very simple. Okay, if you take centralized, right, there is a central authority. Okay, for an example, bank server. Okay, if you take the bank server, right, in this case, it's bank server or Visa server or someone else server, right? Like the transaction is made successful, failure, or any kind of response. Okay, it is the bank server which will give you. Okay, the users of the network or users of SBI Bank or anyone cannot say, okay, that they cannot deny or they cannot approve any kind of stuff. Okay, all they can do is make the transaction, send the request to the server, and the server will give the response back. Okay, this is what they can do. Okay, so at the end of the day, it's the central authority, which is the bank server, which will decide the fate of the transaction. Whereas if you come over here, right, it's completely opposite. Okay, it's here the peers or the people who are the users of the network is itself will decide. There is no central authority at all. Okay, so that is the biggest difference. Okay, so now, okay, so see, I want to explain this particular concept in a very smooth manner, in a very simple manner. Okay, like I want to build the blocks. Okay, from like with a story based stuff and with scenario based stuff. Okay, so now to understand it, right, we all know. Okay, just listen to this particular thing. Okay, nothing else. Okay, we all know account ledger. Like for a moment, just forget about cryptocurrency, everything. Okay, just listen to this. So we all know about this ledger book, right? We used to keep the transactions. Okay, this guy paid me this much, that guy paid me that much. All the transactions will be recorded. Okay, so that at the end of the day we can tally up and we can know what is the profit, etc., etc., etc. Okay, all the companies do. Like, okay, so like there are like 4 friends. Let's say there are 4 friends. Okay, these 4 friends, like they spend for each other. Okay, this guy will pay for this guy and this guy will pay for this guy. But at the end of the day, they all will settle up, okay, with whatever they have paid to the other person, so that there is no issue. Okay, so they do it with the help of this small piggy bank or the pot. Okay, so now if you see, right, so this is the ledger. Okay, like A pays B 200. This is what I told you. Okay, they just save it in this book, and then at the end of the day, whatever settlements need to be made, they will put it in the pot, and the other guys will take it from the pot. Okay, so this is how. Okay, so the person who has spent more than what they receive, they will put the money into the pot. The person who has received more than what they have spent will take the money from the pot. Okay, just see this example, right? Like here, if you see, A is paying B 200, but A has received from D only 100 rupees. So the thing is, A owes 100 rupees, okay? So it will put 100 rupees into the pot so that someone else will take it, okay? Whereas if you see C, right, C is paying D 300 rupees, whereas C is receiving 400 rupees from D. So it will get the extra 100 from the pot, okay? So this is how the pot and this ledger book story works between these friends, okay, which is a very nice settlement process, right? Okay. So now let's dive into the problems, okay? See, the entire idea is there are like many problems, okay? By finding out each and every solution for all these problems, that is how we end up with this cryptocurrency technique itself. That is how the Bitcoin works, okay? So we can just analogously, we can map it out, okay? So we can see the first problem. What is the first problem? Okay, it's public, so anyone can misuse it, okay? So B can simply put A pays 100 like this, okay? So the biggest thing is, if someone is paying me some amount of money, there should be an approval from that someone, okay? So that is the biggest thing. So here, A pays B 100, so A's approval is necessary. So in our life, right, we can take the example of check leaves, right? In check leaves, actually, I will sign and I will give it to you so that you can just encash it. So my sign is very important there, okay? Similar way, there is something called as digital signature, okay? And digital signature is much, much stronger, okay? You cannot even forge it, okay? In like normal signature, you can never, because there is this concept called private and public key, okay? So if you see this, right, like how it functions, okay? See, this secret key is only with you, okay? Only with that person, okay? It's locked, okay? Whereas this public key is available to the entire network, okay? This public key will be available with C, B, A also, but this secret key is only available with B, okay? So now, normally, okay, so it's all the same, right? The hand signature is all same, okay? But digital signature is stronger because it changes with the messages, okay? Like for one particular message, it's different. It's a different signature. For another message, it's a different signature, okay? We use the key message and then we do it, okay? And it's of 256 length, okay? So which is like very huge, okay? So all these things, right, will make, okay, like digital signature are much, much like stronger than the normal signature, okay? Handwritten signature, okay? So I'll put it more formally, okay? So sign, okay, sign, if you take, it will take the message, it will take your secret key, okay? Your secret key is only with you. So now only you can make this, but you can only access this function, okay? No one else can do it, right? So your signature, only you can make it, okay? And then when verifying is coming, you will take the message, you will take the signature, you will take the public key, okay? Now again, you will calculate, okay, with the help of the public key. And then you will check it up with the signature and whether you will return true or false based on the originality, okay? It should match actually, okay? Whatever you are generating with the public key. So actually there is a relationship between private and public key, of course. So actually, how is this possible and all? Like how is this 256 length? It is basically with the help of the hashing techniques, okay, which we'll see further, okay? Further ahead, we will look into how every of these things is working. So as of now, it's actually foolproof, okay? How am I telling is that it's actually 256. You may argue with me, like I'll just find out, like guess the signature so that I can put someone else's signature. You may argue with me this way, okay? But I'm telling you, there are actually, this is of 256 bit length or even more also, depending upon your hashing function, okay? So if you take this, right, like 2 power 256 is a really big number, okay? Why 2 power 256? Because in binary, it's 0 and 1, 0 and 1. So there are totally 2 digits in that binary system, number system. So it's 2 power 256. So if you see this, right, to imagine this, 2 power 32 for 8 times is what 2 power 256 is, okay? 2 power 32 is nothing but 4 billion, okay? So 4 power 8, so for 8 times 4 power 8, which is like 65,536 billion possibilities are there, okay, for the signature. So it's really hard to guess, a very high computation, okay? So now again, like one more small issue is there, okay, we are signing, okay? Like what if the same thing, okay, because this is the message, right, like the sender, receiver and the amount, okay? If it is the same message, then it will be a same sign, right? Like sign 1 and sign 2 will be the same, okay? So instead of like modifying the amount or sender or receiver, if we just duplicate these transactions, okay, by that way, it's again creating an issue, right? So in order to avoid it, right, what we have done is we will be just meddling, okay, the unique ID with the message, okay? So for every transaction, no matter if the sender, receiver and the transaction amount, all the 3 things are same, the unique ID will not be the same. So again, hashing will take care of it. So the hashes will be different, of course, and sign 1 and sign 2, now it will be different. Okay, so now how is overspending issue? There is some overspending issue. So what do I mean by overspending? Let's see that. Okay, so if you see here, right, the entire system is working on trust. Okay, like here, you trust all of your friends. Okay, like all 4 friends trust each other. Okay, so that only, like after the transaction happened, at the end, people will put the money into the pot, so that at the end of the month, again, they will take back the money. Okay, but what if, okay, C is making these transactions, like C pays B, C pays A, C pays D, like this, it is paying to others in the ledger book. Okay, but it does not have real cash to settle up. Okay, this is indeed an issue, right? This is indeed an issue. Okay, see here, C is simply hiding and making the transaction possible, whereas it does not even have that worth of 950 rupees itself. Okay, he does not have. So this is overspending issue. Okay, so to avoid it, right, we again like found one thing. Okay, we again found one thing. Okay, what we are going to do now is that we are going to say, okay, everyone needs to pay some initial amount into the pot, put some initial amount, and we should not spend more than what is being put into the pot by them. Okay, so the first 4 transactions in the ledger book will be A gets 100, B gets 100, C gets 100, D gets 100. It's kind of some prepaid mobile, right? Like instead of like using and then paying back, you just recharge. Afterwards, you use it. Okay, it's kind of that way. Okay, so now let's see, right? Like now, okay, so this is another example, right? Like A gets 100, B gets 100, C gets 100, like D gets 100. After that, C pays A 50, 50, B it pays 50. And then when it tries to overspend, right, it's actually invalidated. This transaction is not even signed, okay, because it gets invalidated, it's not even signed. Okay, so by this way, we stopped, okay, by making some kind of prepaid technique, we just stopped overspending. Okay, so now, now one thing comes, right, like there is now no settlement at all, right, no need of physical cash settlement at all, right, because now, see, you are having this money and whatever you have is what you will spend, okay. And again, the money is being, now the money is rotated, right? Now A will be having 150 and B will be having 150. So now they can spend. By this way, there is some cash flow which is involved just with this money, right? Okay. So theoretically, if you speak, right, if this is a big ledger, let's make, instead of this 4 people, right? Now, if we make it like very huge, okay, like everyone in the world is using this ledger, then no need to have INR or USD, anything, right? All we can have is this, we can name it as ledger cash. Okay. Now ledger cash is completely independent. Now no need to have any other money to make the settlement, because there is no settlement at all. Now all you're doing is revolving, okay, the money, rotating the money between your friends, okay, just in the ledger, which is like completely fine, right? So this is, so this basically, what do I mean from this? Bitcoin is nothing but it's a ledger, okay. Ledger is nothing but it's a transaction history. So at the end of the day, any currency, right, its value is decided upon how much it is being transacted, how much it's being transacted. So how it measures and become independent, let's see. There are people, right, they'll be paying this to companies, okay. And then it's again like it goes to big shots, and again it's been again invested into the companies, and this way like this cycle will revolve again and again. So that is like this proves the independency. What I'm coming to tell is that this proves the independency of cryptocurrency. Okay, there is no need of any support, central authority, anything. Okay, so now let's see, right? Like I told you everything, right? I told you initially it is decentralized, right? So how decentralization is possible? There is no server. How it is even possible? Like you may ask. Okay, so for that I will tell you this thing. Okay, how it is happening, decentralization. Okay, so all these 4 friends, right? They have their own ledger copy. Okay. Now there is no public ledger. Okay. There is no public ledger. Before there was one particular public ledger from which it was shared among these 4. So there was like kind of trust issues and many things were there. Okay. Now what I'm telling is that everybody have their own copy of ledger. Okay. And the transactions are broadcasted. Like if A pays B, it will say A pays B 100 rupees. It will broadcast to every user in the network. Okay, so this is something which is really, again, it's nice, right? So how it is like now, again, some questions, some problems again arise. Okay, so you may ask, okay, so if you're telling the transaction are broadcasted, right, is every transaction stored? What is the order in which it is stored? Is there any protocol to say it's accepted or rejected kind of things, right? So that at the end of the day, all these 4 ledgers should be same and consistent. Okay, that is also our motto, right? More than decentralization, that is very important. Okay, so how does Bitcoin offer the solution for this problem, right? Let's see it. Okay, so the ledger, okay, what happens is that we will accept the ledger, okay, which has more computation, okay, which has the most computation. Okay, so the web of trust here is the computational work. So that what happens is that the fraud transaction are really like so much, okay, like so much of computation is need to be done for the fraud transaction that it is near to impossible. Okay, so the fraud transaction cannot be added into the blockchain. Okay, what happens is that while the fraud is trying to make the blockchain possible, the original transaction has already made it possible. Okay, has already done more computational work, and the length of the blockchain is very high. So that would be now accepted. This fraud transactions would be rejected. Okay, but like at the back end, this is at like very higher level. I told you what Bitcoin is offering, but at the the heart of it is nothing but hashing again. Okay, so now before moving to let's see a small brief about hashing. Okay, so if you take SHA-256, right? It will give you an output of 256 bit. Okay, by taking any input. Okay, and it's like, right, the hashing is one way. Okay, like you cannot get back Bitcoin by using this particular number. Okay, whereas from Bitcoin you can get these numbers. That is what I mean from one way means. Okay, from input to output possible, but from output to input it's not possible. Okay, and also one more thing, like for the same input it's always the same output. These are the 2 fundamental things about hashing. Okay, so now see, only way to break it is by guessing all the inputs, which is not feasible, right? So inverse is not possible, as I told you. Okay, so now now you may ask me, okay, how is this hashing or this SHA-256 is helping for the proof of work, or how it is making sense? Okay, so now I'll tell you. Okay, so the ledger is that, okay, we will put this ledger into the SHA-256 and it will give you the 256-bit output. Okay, this is how it works. So now I will make a particular restriction in the output bits. Okay, what is that restriction is that, for an example, I am setting the first 30 bits should be 0. Okay, should start with 0. Okay, so to do this, right, we will be calculating something called as nonce value. Okay, nonce value is nothing. Okay, it's just a particular value which is used as a base value to calculate the hash. Okay, to put it very simple, this transaction is locked. Okay, you need to do some changes. All you can do is that change this nonce value. Okay, you cannot change the transaction, right? You can change this nonce value so that at the end of the day, when you give this particular ledger into the SHA-256, you will get some output with the restriction being applied. Here the restriction, for an example, I told you as first 30 bits as 0. Okay, so now how finding nonce value is proof of work. Okay, now I'll tell you that. Okay, which is a very important point. How am I telling that? Okay, so as I told you, the initial in the 256-bit initial 30 bits should be 0. This is what the restriction which we made, right? So to do this, right, we need to do again guessing work only. Okay, we will actually be iterating multiple values for the nonce. Okay, we'll be trying it out. Okay, so in case of this, right, 30 zeros, right, it's actually the probability is 1 by 2 power 30. Okay, that means what? Means when you perform 1 billion iterations, right, out of that one particular iteration will be having the hash value starting with 30 zeros. Okay, that is what I'm coming to tell. Okay, so there is a lot of computation which is involved. Okay, it's not very easy to compute. Okay, it takes a lot of time. Okay, and a lot of computing resources also. Okay, so this is how it makes it trustworthy. Okay, so this guesswork will take a lot of time. So that is why it is proof of work. Okay, so and one more thing is that if we change the transaction slightly also, again we need to calculate the hash, and for that we will be guessing the nonce value again, right? So it's again like which makes it like foolproof again, right? So like let's see, okay, how it's been connected. Okay, so these are the transaction, right? Ledger. Okay, these ledgers are actually being connected. Okay, with the help of it's looking like a linked list, right? It's nothing. It's like kind of a linked list, but just look into it, right? Okay, see, every block will be having previous hash, transaction, and proof of work. Okay, if proof of work is there, then only it's a valid block. Okay, so now how is this helping? Okay, let's see that. Okay, see, the thing is, why we are having storing previous hash is that, see, if I'm going to do some fraudulent activity with this block, right? If I'm going to change the transaction, okay, what happens is that the hash of this block will change. Because the hash of this block will change, now for this block, again, like, because this is storing the previous hash, right? So this block's hash will also now change. Okay, so now if this block's hash change, again this block will change. So this chain reaction of invalidating happens. Okay, so that is why we actually store it in this fashion. Okay, yeah, and one more thing is that when you change anything, right? Okay, the hash value of this block changes, and again we need to calculate the proof of work. As I told you, if you change any, like if you make this as 300 instead of 30, right? Like this hash value will again like completely get messed up. Okay, so to get this restriction, like first 30 things should be 0, right? For that, again we need to calculate the new nonce value. Okay, which is again the proof of work, right? We need to go through a billion iterations. Okay, so now, okay, we can see one important concept, which is miners. Okay, like who are the people? Like this is very heavyweighted transaction, right? So who are the people who are going to do this transaction? Are the miners. Okay, we are the people who will be broadcasting the transactions, and these are the people who will calculate the proof of work for us. Okay, so how it happens is that, see, it will listen to all the transactions, it will make the block, and one more special transaction would be added, that is the block reward. Okay, which is what goes as an earnings for the miners. Okay, so miners' job is to calculate the proof of work. Okay, and all the miners will be in a race. Okay, to calculate the correct nonce value. If they calculate the current nonce value, then only they have done the proof of work for this block. Then only this block will be valid. Okay, so by this way, everybody would be in a race. Okay, so at the end, okay, I'll just summarize like what miners do. Okay, we are the users. There are many users who wants to transact. Okay, they will make the transactions. Okay, they will broadcast the transactions, that they will say A is paying B 100 rupees, B is paying C 100 rupees, like this. Everybody would be making some transactions. Okay, all these transactions are broadcasted. Okay, the miners will listen to these transactions, make the block. Okay, make the block, calculate the proof of work, that is nonce value, by iterating. Okay, everybody would start the iteration. That is how the race starts. Okay, someone, the guy who first finds out the current nonce value, has done the proof of work for this block, and now he has validated this block. Now what he will do is that he will broadcast this block back to the network, so that now the user's responsibility is to take this block and then append it to the blockchain. Okay, now so as I told you, right, now the users no need to like perform mining activity and all. Okay, no need to calculate the proof of work. It's not user's job. Okay, now no need to listen to everyone's transaction also, right? Users don't need to listen. Like for an example, A is paying B 100 rupees. C does not need to listen to this transaction. Okay, it is the miners who needs to listen, and a user can also be a miner also. Okay, that is a separate case. Okay, but now all the users no need to listen to everyone's transaction. This is the one of the biggest advantage now we have got. Okay, all they need to do is the job of miners. Okay, they will listen to the transaction, they will make the block, and they will broadcast the block. Now instead of listening to everyone's transaction, all they need to do is that they need to listen to all the blocks which are being broadcasted by the miners, so that they can append it in their private copy. Okay, so now there are some conflicts again, right? There is no stop for this. Okay, there will be a lot of problems. Okay, so now if you see the problem, what is the problem? If you see, right, here A is actually like here what A is doing, like let's say like A is some fraud. Okay, he's a fraud. making person. Okay, what he is doing is that he is telling A has paid B 100 cash, okay, bitcoins. It has paid B. That is what A is telling. Okay, it is trying to make this transaction with a block. Okay, it is also a miner. Let's assume it is also a miner. Okay, so it is trying to affect the blockchain of B. Okay, by making this fraudulent block, because it is itself calculating the proof of work. Okay, so this kind of issues there now, right? So to resolve this issue, we have some thumb rule called as high computational work is what we will choose. Okay, so basically in the blockchain, the longest one is the more computed one, and more computed one is the valid one also. So how it is now, like how it is tackled, let's see how it is tackled. Okay, so here if you see, right, like this blockchain, this is blockchain of B. Okay, it is its private copy. Okay, here A is simply trying to add its block, okay, the fraud transaction. Okay, whereas these are the blocks which are added by the miners. Okay, see, at the initial point the length will be the same. Okay, but later on because the miners are more, right, A is just one single miner. Okay, there are like a lot of miners. Okay, they will be adding the correct transactions, right? They'll be adding the correct transactions. Okay, so eventually what happens is that at a later point of time, the longest blockchain will be the ones which other miners have had. The whatever blocks which is added by A will be lesser, because there is something called as proof of work. Okay, that needs to be computed. Okay, that takes time. For example, proof of work takes 5 minutes, right? For A, it will take every 5 minutes to generate a block. Whereas if there are like 10 other miners, right, 10 blocks is generated for every 5 minutes, right? Proof of work time is same for every miner, but there are 10 miners in the opposite to one miner, that is A, right? So by this way, we will be tackling, okay, the conflicts like double spending or the fraudulent transactions. All these things can be handled this way. Okay, now again, one small loophole is there, right? As I told you, it's the majority, right? Here the majority is deciding, right? Who has more power, who has more manpower will decide, right? What if you say there are like 51% of the people are like supporting A, let's say, like they are supporting A and they are like mining the same block with fraudulent transaction and appending it. Okay, so now it's an issue, right? But okay, this does not happen with famous cryptocurrencies. Okay, like if you take blockchain, right, Bitcoin, right, it has almost by 2021 itself, it has almost 18.74 million miners. Okay, miners are there. Okay, so it's really very tough. Okay, to make like 50% of these miners, like it involves a lot of computation. Okay, it's not that easy. Okay, to make this possible. Okay, so by that way, practically it's impossible, but theoretically it is possible still. Okay, this one loophole is there, 51% attack. Okay, so now let me come. Okay, what is the average block time? Okay, so if you see this, right, for Bitcoin it's 10 minutes, for Ethereum it's 15 seconds, and for other coins these are the times. Okay, so what does it mean? Means for every 10 minutes there is some miner who is winning. Okay, and he gets the block reward. Okay, because he has calculated the proof of work. How? By calculating the correct nonce value. This is how he has done it, right? Yeah. So let's see what is like block reward. Okay, so block reward, how much was being paid? Let's see how much it is being paid. Okay, around 29 and 12, it was 50. Then it was 25 from 12 to 2016. From 2016 to 2020, it's like 12.5. From 2020 to 2023, it's 6.5. You can see a trend, right? It's always half. Okay, it's getting geometrically, it's actually decreasing, right? So from this calculation, right, if you make a calculation, right, at a point this block reward is going to become zero only. Okay, so if you see this, right, there can be a maximum of 21 million bitcoins only. Okay, after that, that's all. It's a saturation. It's now going to be just a transaction between the people. Okay, now you may ask, if there is no block reward, then why the miners are going to do it? Okay, so there is something called as transaction fee. Okay, this is an alternative way for miners to earn money. Okay, basically because the block reward is eventually going to fade out as the time goes. So what happens is that now the transaction people, right, the users, right, now the users themselves are going to add a small transaction fee. For an example, if A is paying B like for 0.45 Bitcoin, right, then this amount of Bitcoin is being paid to miner as a transaction fee. Okay, this is actually appended in the transaction itself, in the existing transaction itself. There is no special transaction. Now there is no special transaction which has been added. It's the existing transaction according with that itself it's been appended. Okay, with the A's approval. The thing is with the A's approval. Okay, there is no new coin generation which is happening. Okay, so we must understand this difference between block reward and then the transaction fee. Okay, there is no block reward. New coins are being generated. Okay, into the market. Okay. Whereas in the transaction fee, right, there is no new coins which are being generated. It is actually A's coin only. Now A is being paying like 0.45 to B. Okay. At the same time, 0.001 Bitcoin, it is taking from its own pocket and giving it to the miner. Okay. So that this actually incentivizes the miner, because miners can actually in Bitcoin, miners can choose what transaction they need to work with. Okay. So if the miners need to work, they must have something, right? So that is a transaction fee. So this way, the people who want to transact will add the transaction fee. Okay. So to make it very simple, just think like the PhonePe wallet transaction which you make. Okay. For mobile recharge, if you go and make, right, for like 100 rupees if you want to recharge, for that 1 or 2 rupees is being taken as a convenience fee and transaction fee by PhonePe, right? Similar way, it's done. Now it goes to the miner, not to some specific company. It goes to the person who is mining, okay, who is calculating the thing for you, okay. So now comes the last thing, right? Like, shall I also be a miner? Okay, so it is actually a very complicated question, because the software, the technology, everything is like a bit complicated. And also the hardware resources are very high. Okay, so because in the starting days it was some simpler, okay, some high-end graphics card itself was working out, okay, but nowadays like apart from CPU GPU powers, you need special miners for it, okay, which is being sold in the market, and that is really very costly. And with that, like the electricity consumption for this complicated devices are also so high. Okay, so because of all these reasons, right, like making profitability, okay, at the end of the day, like the block reward is like going off, right, and the miners are completely going to be dependent on the transaction fee. So when this happens, right, like by investing this amount of money and then like making this is something, it's a big question mark. Okay, so it's a point which has to be like thought, okay, very deeply. Okay, so now thank you very much for looking into my complete lecture. Thank you.